All right, in this video, we're continuing to work on the Chevelle LS Turbo Build, and in this video, we are going to be welding up all the intercooler piping. Okay, so in previous videos, first off, I got this air-to-water intercooler set up from Ichiban Moto, so check out that video. I got this stuff for free. I had to buy a few couplers and clamps and boots and some extra piping just to practice welding. Second of all, I 3D printed a template, so check out that video just to kind of visualize what I need to do and if I wanted to make that run versus actually cutting metal. 3D printing's cheap and easy for me, so that was in that video. And then we did some welding with this new welder that I got from Prime Weld. It's the TIG 225X, so make sure to check out that video where we unbox it and lay a few welds. And then a couple weeks ago, I welded my very first part, which was kind of difficult to do because it was a pipe to a cast aluminum timing cover. So that actually went pretty well considering I really don't know what I'm doing at this point. So now this is the second project of a real part that I need to do, and it's welding up 3-inch pipe. And I had a little more practice, and we'll see if I can do this. And also we got to mount the blow-off valve. And I want to take a minute and thank everyone who commented on that last timing cover video. Instead of people bashing my welding skills, they were supportive and they actually gave me a lot of good information. So thank you for that, because I'm a total newbie to welding and I'll take all the advice I can get right now. I'm watching a lot of videos. I get input from you guys. So thank you for that. Thanks for not being armchair quarterbacks and freaking yelling how bad my welds are. So thanks for that. Okay, so if you remember in a previous video, I did all these pie cuts out of 3D printed material and I kind of made a template, right? So what I did is I kind of went and cut up some pieces to get, you know, close to this, right? Printing pie cuts is ideal because printing each of these is simple. If I can't print huge tubes like that, especially like this one. So this just kind of gave me a way to visualize, you know, I have a hard time visualizing things. So anyway, here we go. I made these cuts and now we can clock these any way we want. We'll go to the car and we'll tape these up and then we'll tack it, and that should be the top section. Now as far as the bottom tube, this is what was on the car, and I was able to cut this tube to kind of match up, and instead of doing this 45 coupler, I'm just going to do a straight coupler here. So this is one tube here ready to go, and that's it. So those 3D printed parts were helpful, but now we got this, so let's go ahead and mock this up in the car. All right, so I want to talk about how I cut up these aluminum parts. This guy here is just to support this with this blade. It's a little heavy on the saw, so I just got this guy here just to prop that up. Okay, so I bought this abrasive cutoff wheel chop saw for like 25 bucks on Craigslist. Normally these things are like 200 new, so it was awesome to find that. What I did is I bought an aluminum 14-inch cutting blade, and this thing rips through the aluminum like butter. Okay, couple tips. Wear long sleeves, gloves, a face shield, and ear protection because the chips fly off of this like crazy, and they're hot and they burn. So just wear all that protective gear when you're using this, and it's loud. Okay, so definitely wear earplugs. I can't stand the noise. Secondly, it started. I did this outside. Don't do it in your garage. The chips will be everywhere. They fly far too, 10, 15 feet. So I did this outside, and guess what? It started drizzling. Sweeping up wet aluminum chips is impossible. I had to take out the shop vac and shop vac my whole driveway, and the chips were everywhere. Okay, so don't do it when it's raining out, all right? Anyway, so this guy had a quick release. For a lot of this, I couldn't clamp this guy here because of the goofy size. So like if I needed to cut like this, I kind of had to hold it really tight and just plunge the saw. Okay, and then for the 45-degree cuts, what I did is I measured the middle and then just hit this with a speed square here and cut it at 45, and I couldn't clamp it, so I just kind of had to do this, and I eyeballed it and I held it and I just wham, cut it. Okay, so this works great. Just unfortunately you got to take those protective precautions, and the chips go flying everywhere. So that's how I cut everything, and I didn't get that on video because it was raining. I didn't want to get my camera wet. Okay, let's start off with this bottom tube. I cut it down, and pretty much it's gonna go right here just like that. So let's go ahead and put this stuff together here. Okay, so that pretty much takes care of that one. I could probably cut this one a little shorter, or I can even like clock this turbo a little bit, but basically that's right on the money. No beaded ends on this one or anything. I got about a 1/4 inch or more right here. I can just stick my index finger in here to the radiator, so that's cool. So yeah, that one was easy. Now let's work on this one here. All right, so we'll start off with this guy here. Okay. Okay, we'll jog down. And I'm joining these pieces with PET tape. This is high temperature tape. And what it'll allow me to do is I'll cut a section out, and I'll be able to tack weld these while it's taped up, and that way, you know, it'll just be easier. Okay, so I'm going to cut a piece ahead of time here. Okay, so we're going to want to go down and around the turbo here. And again, we can clock these all kinds of ways here. Okay, and I just got this piece here for mock-up. Okay, so this piece looks pretty good right there, so I'm going to line it up. Get my tape. Alright, so that's a nice tight joint right there for that one. Alright, so this guy's going to go on here. This is going to go something like this. Alright, that is pretty close. I just need to adjust things here. Alright, so I'm going to make a mark right here. Let's tape this guy up. It's close enough. Alright, so these two are taped up. That looks good. Now I'm just going to play with this a little bit to get it tight. Okay, so that's looking good right there. Let's tape that up. Woo! That took a while to finagle, but I got it. That's where I want it. All right, here's a better look. The bottom tube, no sweat, straight shot, right? This one here, I want it to jog down below the turbo. I got a 1/4 inch or so to the fan, and I got about a 1/4 inch to the belt, so it's pretty close. And of course, I can, once this is all tacked up, I can angle it a little bit and get a better fit. But it's tight, man. But you know, I think that's gonna work out pretty good. Okay, so it's taped up. What I'm gonna do is I'm gonna slice a section away so I can put a tack. And this tape supposedly doesn't melt or leave residue or anything. So if I just kind of come in here and slice a little bit of it away, I can lay down a tack without destroying my, you know, my clocking. All right, good spots for tacks right there. By the way, these parts have been vapor blasted and they're clean. All right, kind of a crappy tack, but I'll take it. This tape was melting away, but it doesn't leave any residue, so whatever. Good tack on that one. All right. All right, awesome. I'll flip it around and do a tack on the other side as well. All right, so that's a pretty good tack there. That was a big gap there, so I'm kind of happy that worked out. Okay, so at this point I have 2 tacks everywhere. Let me peel this tape off and we'll get a closer look. Let me let it cool down. Here's a close-up of one of the tacks. There's a nice crater there. I kind of put a little too much heat in there. But the residue comes right off. And hey man, it's tacked, it's cooled down. Let's freaking test fit this thing. And I pretty much practice on one piece here, and I'm feeling pretty comfortable. I mean, well, as comfortable as I can get with how little time I had with this machine. And this is my first time doing 3-inch pipe. So, you know, this is my first go at it, and I'm like, screw it. Looks good enough. Let's not waste any time practicing. Let's just go right for it. So let's mock this up really quick and then see if we're good. And see what I mean? I can move it and twist this to get the proper clearance everywhere. So yeah, that looks really good. So there's a tight spot here near the belt. I have a good quarter, half inch there, quarter inch here, and of course I can, you know, rotate this however I want, but that's kind of it. Now it's time to fully weld that piece up. Okay, so now it's just a matter of welding it up. I hit this with acetone, cleaned my filler rod with acetone, so let's just give it a go. All right, so there's that first pass. That looks pretty good. And I'll probably jump from one joint to the next because, you know, there's going to be a lot of heat added in here. So I'll just jump around a little bit. Okay, the part's fully welded up. These welds, they're gonna work, but you know, some of them don't look too good. Over here, too much heat. This part, you know, I just kept going on this joint, and once you keep welding, you actually have to throttle back on the pedal because the part gets so hot, then it just doesn't take that much heat from the torch. So over here, towards the end, this was just getting really hot, so I got a lot of penetration here. And over here, since this was on a compound curve, it was going this way and that way. It was really hard for me to travel with the torch, so I kind of got a little squirrely there. But in any case, I mean, you know, overall, I'm happy with these. I mean, I practiced on one piece, and I just went for it, you know. And then over here, You know, some of these look really nice, right? But then I get a little squirrely and whatnot, and I'm starting and stopping all the time. But whatever, it is what it is. Okay, and then over here, if we look in the pipe, I am definitely getting penetration. I mean, I can see that it's getting down in there. So obviously that's something I'm trying to learn. Basically what I'm looking for is I'm looking for the puddle to drop, and then I add my filler, and then I move. Once you see that puddle drop, then you know it's penetrating, and you know, it's just getting used to all that. So yeah, this part was kind of crazy, and getting this part angled on the table to where you're comfortable and you can hit everything is kind of a challenge. Obviously, this is kind of a wonky ass part, but anyway, let's go fit it up in the car. All right, here we go. Goes this way. Jam it way in there. All right. Okay, so yeah, that fits really nice. Let me roll it a little bit to get more, or this way, goes that way, yeah. So once I clamp this down, it's gonna be good. Yeah, so 1/4 inch here, 1/4 inch there, that's it, man. So, and I could probably roll it closer to the fan and gain more clearance to the belt. I mean, the fan, there's a shroud here, nothing's gonna go in there. So that looks great. Now we got to put the blow-off valve, so that'll be the next step. One thing I want to mention is there's no beaded ends here. I'm going to try running it without. I mean, it's a pain in the ass to get these couplers in here without silicone spray. And once I have the clamps on here, if you think about it, there's no way this pipe can blow off. It can't blow off this way because this guy's holding it. It can't blow off that way. I think this is going to be the weak point. I've seen dyno runs, and this guy always blows off. And it's just a crappy fit. This is a 4 inch. It's just a weird, like 3.8 inch throttle body size or whatever. So I think this is always going to blow off here. But I just noticed something. It's going to be hard to blow off because it's hitting the fan. Okay, so that might all work out. Whatever, we'll see what happens. All right, so I mocked up the blow-off valve. I had to do a little grinding on this part. It's taped in place, and basically I'm going to put it right here. Okay, and I'll explain my reasoning on placement after I weld it. Woo, not bad. Oh man, that was uncomfortable as hell. Well, let me get a shot of that. That looks okay. Not too bad. I'm using more amperage, like 90 amps on this fillet, and oh man, it's a lot tougher than a butt joint, that's for sure. So let's keep going. All right, this weld was tricky, but dipped my tungsten a few times. You know, had the edge. This edge for this part keeps melting away. It's definitely difficult. Whatever, man, it's on there. And then here, I did get a little too much penetration in some areas, but whatever. I'm gonna take a hole saw, punch this out, and then vapor blast all the residue. I forgot to peel the freaking tape off here, and it just totally cooked on there, so I have some cleanup work to do, but overall, I didn't screw it up. Okay, let's talk about the machine settings I used, and I have the machine off. The fan's kind of noisy, so the only thing you would see if it was on is this readout, and I'll just tell you what it was. It's the amperage. Okay, so we're doing TIG and AC, so both these rockers are flipped up. AC frequency is 12 o'clock. I believe that's 120 hertz. AC balance is right here at 10 o'clock, which is 30%. Okay, now let's jump over here. We're doing 2T, which is the foot pedal. So this guy, this guy, this guy, and this guy do nothing. Doesn't matter what position they are ignored when it's in 2T. So the only knob you got to deal with is this. So for the butt joint, I use 70 amps, which is 7 in it, because the material was roughly 70 thou thick. For the blow-off valve, which is a T joint, so to speak, the fillet weld, that requires more heat, so I bumped it up to 90. Okay. Pre-flow, I don't know how long this is, but I got this guy at 12 o'clock. This one we're not using, this one we're not using, this one we're not using because pulse is off. And then post flow is, I don't know, 11, 12 o'clock. So those are the settings that I used. Argon flow, 15 CFH. As far as the torch setup, this was the stick out for the blow off valve. I had a little less stick out for the butt joint. This just helped me see a little better. Same flow for both. I'm using a number 5 cup that came with this machine, and this is 3/32 lanthanated tungsten, I believe, and I ground it down to a blunt tip, and over time it kind of wears into a ball. That's just what I did. Okay, so anyway, that's the torch setup. As far as filler rod, ER 53, 56, 16th of an inch thick. So I use this both for the butt and the fillet. The fillet weld, or the T-joint, sorry, will take more filler. So sometimes I even, maybe even 3/32 would be okay for that. Okay, so obviously I cut up the tubes, right? And the tubes initially had this beaded rolled end, right? And this would be awesome to have, so the couplers have a less tendency to blow off. Okay, so you can see I have these. An option would be to cut these down and obviously weld these stubs on the piping. Now some of my runs end in an arc, so putting a straight on would kind of it wouldn't work too well. Okay, now I bought these a while ago, and what these are weld on beaded ends from Monkey Fab, and how they work is they slide on to the tube, and it's a nice tight fit right here. And he claims that just stitch it, so like 1, 2, 3, 4 spots on the inside, just weld it. Okay, so that's certainly an option. I only bought 2 of them because I just wanted to check them out. So I'm not gonna put these on just yet. Okay, I'm gonna try running it as is. Obviously the car's not gonna be on the road until spring, but if they blow off, then this is what I'm gonna have to do, and I'll have to trim a little bit off the runs, a 1/4 inch or so, and then weld these on because they do add a little bit of length. But the reason I'm not doing it is because I'm probably gonna have to practice more. I mean, getting in here and welding for me is gonna be tricky. Okay, so I'm gonna hold off on that, but I just wanted to kind of show you these. These are pretty cool. It's a cool solution because a bead roller is like a couple $100 or whatever. And remember, I am terminating on an arc, very close to an arc. There's very little straight, so I don't think a bead roller would work in my situation. So this would be the fix if my couplers blow off. Okay, so Monkey Fab Garage. Check him out. I buy a lot of stuff from him for this build. V-bands, these, welding equipment. So he's a super cool dude to deal with. So check that out. Okay, so it's all done. All the clamps are on there nice and tight, and this thing, everything is really rock solid. This guy's a little loose here, but I'm really happy the way it came out. Now let's talk about this blow-off valve. First of all, I would have liked it a little more this way. I think it moved on me when I was welding. It's just a funky part on a funky curve. The tape was melting, and actually I was trying to tack it and it shifted. Oh well, it still has plenty of clearance for what it needs to do. Now, in terms of placement, you're probably wondering, why did I put it here? Typically it's put as close to the throttle body as possible. I didn't have any room here, and then if I put it here, it would have just been a goofy weld, and it just didn't look right, okay? And then there's some people on the internet that you say, hey, it should be close to the compressor, close to the turbo, not the throttle body. So there's two schools of thought there. And if you think about this, a lot of people don't even run a blow-off valve, okay? And then secondly, look how short this piping is. It is 3 feet, 4 feet long. The minute this thing opens, it's going to instantaneously release all the pressure. I don't think, it's a small detail that I don't think is going to matter for my application. So I just put it there because it's packaged nice. It looks cool there. I would have liked it a little more this way. Whatever. I do still have to put some plumbing in here for a water hose inlet into the intercooler, so that's in a future video. But in any case, I'm just amazed that I welded all this stuff up and I didn't screw it up. No scrap. It worked. Do they look pretty? Not really. But, it works. And I vapor blasted everything, and you can see that the vapor blast really cleans up the weld. It cleans up all the smut or whatever, and then it gets rid of the cleaning action lines. So I kind of like this look. Now I do have a buffer and a polisher. I can buff these to shine it up, but I actually kind of like this vapor blast look. It matches the rest of everything. And then no one's going to have pipes that look like this, right? They just look a little different. They look like they're spray painted. It looks fake almost. And, that's what I want to do. I want to trick people, right? So anyway, that's that, man. I can't believe I was able to do this. So yeah, that's it for this video. There's plenty more to do. I'd still have to build a little water tank, a square box essentially with a cap and input-output for the water system for this air-to-water intercooler. So we will put that on the other side. There is absolutely no room over here. So stay tuned for that in the future.